I think it's time to start. Welcome and thank you for joining us today. My name is Anastasia Papas and I'm the founder of the Access Forum, a nonprofit research organization on macroeconomic policies and sustainability. This is the second webinar of our fall series, and it's a great pleasure to have Roland Bénabou presenting his paper, Environmental Preferences and Technological Choices, Is Market Competition Clean or Dirty? Roland is a professor at Princeton University and holds a joint appointment in the Department of Economics and the School of Public and International Affairs. His research spans both microeconomic and macroeconomic areas. His recent work lies in three main areas. The first links inequality, growth, social mobility, and the political economy of redistribution. The second centers on education, social interactions, and the socioeconomic structure of cities. The third is that of economics and psychology, i.e. behavioral economics. Roland is a member of the American Academy of Arts and Sciences, Fellow of the Econometric Society, Research Associate of the NBER, Research Fellow at CEPR, Senior Fellow at the Canadian Institute for Advanced Research, Research Fellow of the Institute of the Study of Labor, Senior Fellow of the Bureau of Research and Economic Analysis of Development, and a member of the Behavioral Economics Roundtable. He's currently a co-editor of the American Economic Review. In April, Roland was awarded the 2021 Jean-Jacques Lafont Prize by the Toulouse School of Economics, which is given to renowned economists whose research combines both the theoretical and the empirical. But before I pass the floor to Laurent, as always, I will ask you to respond to our survey questions. Responses are anonymous, but they always help us understand what our audience thinks about the subject in hand. So the first question is, how have pro-environmental attitudes evolved between 2000 and 2010, in your opinion? Consumers became more environmentally concerned, consumers became less environmentally concerned, and there was no change. The second question is, in your view, what's the most effective way to promote green innovation at the firm level? Environmental regulations and or taxes, green R&D subsidies, competitive industries complemented by pro-environmental attitudes, all of the above. Just a minute to... Okay, so I guess the majority of the people, 90% think consumers became more environmentally concerned. That's interesting. The second question, 52% think that environmental regulations and green R&D subsidies and the competitive industries complemented by pro-environment preferences contribute to promoting green innovation at the firm level. That's good. Okay, just to remind you that your questions, you can write them on a Q&A function. If you want to ask them yourself, you can raise your hand. Otherwise, I'll be happy to ask them for you. So Roland, the floor is yours.
Okay. Thank you, Anastasia, for this very nice introduction. And it's a pleasure to be here, at least virtually. I will share my screen now. Is that visible by everyone?
Yes.
Yes. Okay. Yes. All right. So this paper is joint with Philippe Aguillon, who's at Collège de France, Ralph Martin, who's at Imperial College in London, and Alexandra Roulet, who is at INSEAD. And it's kind of a combination of endogenous growth theory with a focus on environmental measures or environmental consequences of growth, and a bit of behavioral thinking related to social responsibility of individuals. So, okay. So the standard prescription for market failures, and the one we're going to be talking about here is, climate change. Pollution is some form of government intervention, tax and subsidies, regulation, tradable permits, etc. And indeed, that was, the number one recommendation, so to speak, in the little survey that we just had. As I said, this has been studied for a while. It's been incorporated in an endogenous growth model, and we kind of understand how it works, at least in theory, because in practice, it's often very hard to implement these standard climate-friendly policies. People rebel against gasoline taxes, carbon taxes. There's a picture here of the French Gilets jaunes, who, as you know, kind of paralyzed France for much of a year. And it started with a very minor increase in fuel prices, less than 10%, something like 5%. And then there are lobbies, maybe more relevant in the US, So the number one tool, of course, should be on our list, but very often its usability is limited. At the same time, and probably for that reason, we see increased demand and willingness to pay from individual consumers and investors, and here I'll be focusing on consumers, to do their part for the environment or other externalities such as poverty, greed or fair trade, activist campaigns and boycotts, buying an electric car, even though it's not, quote unquote, individually rational, and so on. And also even though it has zero effect on aggregate pollution at the individual level. So what we want to ask in this paper is both theoretically and empirically whether the fact that people have these intrinsic motivations to do their part for the planet can effectively translate into cleaner products through the innovation channel by incentivizing firms to develop cleaner products and to sell them, of course. And secondly, how does market competition among these firms matter for the response to citizens' demand for social responsibility? And how does it matter per se? Okay, so you can tie this back to various literatures. On the social responsibility side, we have the classical work of Milton Friedman, who says firms' business is to maximize profits. Any correction between private and social incentives is the purview of the government. As we said, yes, maybe in theory, but in practice, there are many reasons why this doesn't work. On the other hand, we have a list of reasons that I've mentioned here and listed some down on this slide, why very often these tools are limited. Okay, so these are the questions we're going to look at. And first, I will show a bit of the theory. There will be a model of innovation, because that's what it's about, in which we have firms who can make what we'll call clean innovations, make their products or their production processes less polluting. And then we have consumers on the other side who have some preference, some ethical preference for consuming cleaner products. Okay, and this is going to interact with market competition in an intuitive way, which is that firms, don't like to compete à la Bertrand on prices. If you can differentiate by being greener or cleaner than your competitor, then you will invest and try to be that. And the more consumers are concerned about their environmental footprint, the more is the incentive. So one of the main results is that these two forces are going to act as complements in tilting innovation in the cleaner direction. Then we're going to test these predictions using patent data for the outcomes and surveys on attitudes and on competition for the so-called inputs on the car industry. Okay. Let me go directly to showing you a bit of the model. So the model is going to have firms that choose how much to invest in cleaner technologies with the objective, as usual, of maximizing end-of-period profit in every period. R&D that we focus on improves the cleanliness of the technology which they produce or other, when you consume their goods. And they compete for consumers who care both about getting a good deal and about their footprint. So let's see how it works. There's going to be a continuum of differentiated goods. Good J is going to be produced by various firms, potentially. In practice, it's going to be 2 firms. And if we're going to note its quality QJF, that is the production or the consumption of 1 unit of this good generates 1 over QJF units of emissions, carbons or whatever else you want. Okay. Now, consumers have standard taste for variety across goods, which we can see here with an elasticity of substitution equal to 1. And then, for each good, they will choose among firms depending on the cleanliness of those firms' products. So it should be this integral here should be over F, not over J. So each firm's consumption is weighted by its quality with a coefficient delta, which captures how much consumers are concerned about the footprint of their consumption, YIF. Okay. Now, given that within a good F, these quality adjusted consumptions are perfect substitutes, in fact, all demand is going to go to the firm with the highest quality price ratio. And because all goods are symmetric, we can normalize the amount that is spent on each good to 1. And so consumers will end up spending 1 unit of the numeraire consumption good on each variety. And for each variety, they will go to the firm that has the highest environmental quality relative to price ratio. Okay. Now on the production side, firms produce using labor, which is infinitely elastic. We're going to normalize the wage as to 1 as well. And then firms, can engage in innovation, or they can also copy innovations from the other. And we're going to put their qualities on a standard quality ladder. If a firm F has made K sub F innovations or has copied K sub F innovations, its quality has grown K sub F times by a factor gamma, where the gamma is measures, how important is the emissions reduction of a standard innovation. Okay. Conversely, if you think in terms of costs, if the producing a unit of good costs C, then producing a unit of quality adjusted good or quality adjusted output becomes cheaper when you have made more innovations. That is when KF is higher, and also when delta is higher, which means that consumers care more about each unit of improvement. Okay, so how do you get to make these innovations, or in general, how do you get to produce cleaner products? You have to, or at least someone has to invest. So there's going to be some standard convex cost in terms of R&D that you have to invest. And if you invest Z units, there will be a probably Z or minimum of Z(n)(1) of inventing a technology that is one step better than the existing one, than the frontier, that is gamma cleaner. You increase your K by one step. We'll call this Z the innovation rate or the R&D intensity of the firm. Okay, now a little bit more about market structure. Each good is, so remember, there are all these goods that consumers care about differently with an elasticity of substitution equal to 1. In each sector, there are essentially two firms that are going to be producing, two duopolists, A and B, and there will be a competitive fringe that, that may enter, but in equilibrium will not enter, but will constrain the prices that can be charged. So under some assumptions that are in the paper, which are, I won't go over now, at each point in time in a sector, it could be that the two firms have the same technology, the technology is equally clean. We'll call those leveled or neck and neck. They have the same K, KA equals KB, or unleveled. That is, one firm is ahead, one firm has had one more innovation than the other, and equilibrium, there'll never be more than one for simplicity. So there's a leader whose technology is gamma times better that of the follower. Okay, so what, the equilibrium or solving for the equilibrium consists in kind of solving for the R&D intensity of each firm, this Z that I've described here, what Z do firms choose, and then from that deriving the probability or the fraction of sectors in which firms will have had the same number of innovations or one firm will be ahead. Okay, now suppose that we are in one of these so-called unleveled sectors. So the leader has a quality advantage of gamma to the power delta as seen by the consumers over the follower. So what they can do is they can engage in limit pricing. They can choose gamma delta as a markup over marginal cost, and the other competitor just cannot compete. Then de facto we have a monopoly that's going to have this price, and since we have log utility, the output is going to be 1 over this quantity, and the profit margin is going to be increasing in this quality advantage as perceived by consumers. That's what we call pi m, the monopoly profit. And any sector in which if one firm has gotten ahead of the other by a step, that's the profit level. The reason why there are never more than one step ahead is an assumption we make, which is that at the end of the period, the follower can costlessly copy the innovation that has been made by the leader. Okay, so your advantage lasts only for one period, and at the end of the period, during that period, you reap these monopoly profits. At the end of the period, everything is reset to 0, so to speak, and you have to, someone has to invest again to get ahead. So some sectors will have this kind of monopoly structure, de facto monopoly structures. Other sectors will have two firms that are equally good in terms of quality, and then they'll compete. Now, they may compete very hard, à la Bertrand, driving the prices to the marginal cost and making 0 profits. That's not very good. Or they can engage in some kind of collusion or other, departure from perfect competition, which we don't measure, model explicitly, but we're going to parameterize by some degree of competition. Okay, so if they colluded perfectly, then they would act like a monopolist, earn profits pi m, and each of them would have pi m over 2. So anywhere in between, we're going to define product market competition varying between 1/2 and 1 as the extent to which firms are able to depart from Bertrand. That is, the profits made by a duopolist in a market with degree of competition delta are a fraction 1 minus delta of those of a monopolist. So if delta is 1, that's perfect competition. We had Bertrand, we had 0 profits. If delta is a half, then everybody or each one makes pi m over 2. That's perfect collusion. Okay, now corresponding, how do you achieve that level of profit? By agreeing or colluding on a certain price level, which is easy to back out and which is written here. And then once again, the output of the sector is going to be inversely proportional to the price level because of log preferences. This price level or this inverse of the price level, depends in the way that you would expect on the degree of competition in particular, and also on how much consumers are willing to pay for quality. Okay, so we know what happens in a sector where both firms have the same technology. We know what happens in a sector where one firm is ahead. So let's take the beginning of any period and let's see how hard they will compete to try and get ahead. So you're a potential innovator. You're going to choose your degree of R&D intensity to maximize expected profits at the end of the period. So with probably Z, you will succeed. And for simplicity, we assume that only one firm has an opportunity to invest. It's a minor assumption, but simplifies things. So with probably Z, you'll succeed and become a monopolist. With probably 1 minus Z, you will not succeed and remain a duopolist and earn profits that are high or low depending on the degree of competition. And then there's the cost of that investment. Okay. For an interior solution, we get a very simple solution. That is, the intensity of R&D is equal to this right-hand side. It is clearly decreasing in the investment cost. It is increasing in the degree of competition. That's the so-called escaping competition effect. The harder is competition, the more you want to differentiate yourself by being cleaner or having higher quality than your competitor. And it is, of course, increasing in this quantity, which is the monopoly profit, what a monopolist can charge, let's say, over a competitive fringe, because they have a product of higher quality. Okay, so we have these firms, they're all ex-ante symmetric. They will invest a fraction Z in each period. So in each period, a fraction Z will succeed in, with probably Z, so a fraction Z will succeed in getting ahead, and fraction 1 minus Z will not. So there'll be the proportion of sector where innovation occurs, or the intensity, total intensity of innovation is just this Z of delta. Okay. So we have a very simple formula that tells us what is the intensity of R&D. In our case, it's to improve quality, and in particular environmental quality, as a function of competition, as a function of delta, which is how much people or consumers care about the environment, their environmental footprint, and also about gamma, which is a kind of a production parameter. So here's the first proposition. Both more market competition, big delta, and consumers' social responsibility concerns. So if we change their preferences so that they care more about they have a higher willingness to pay, not to pollute, not surprisingly, is going to increase the flow of innovations, which in the model are clean innovations that we focus on. More generally, you could have clean and dirty innovation. That's what's going to be in the empirical analysis. So really, you should interpret this result as the ratio of clean to dirty innovations. And then this key result here, which is that the two are complements, as you can see from this product formula. So the more consumers are, the more socially responsible consumers are, the more clean or the less dirty competition becomes. And conversely, the higher is the degree of competition, the more the social responsibility of consumers will have an impact, will be leveraged as firms compete for that. Okay, so that's the model. These are the comparatives, these are the variables on which we can get data: innovation, competition, attitudes of consumers. So this is what we'll test empirically. But before we get there, I want to talk a little bit about, at least the theory side of things we really care about. We care about innovation, not per se, but because, it leads to cleaner products, which leads to less pollution, which maybe improves welfare. So in the model, we can actually compute how much pollution is going to happen in equilibrium. Okay? So if the degree of competition is delta, we know that there'll be one minus z of the sectors will be neck and neck, and they will produce this y of delta that we described before. And a fraction z of the sectors, one firm will be ahead. It will produce the lower, it will produce the, excuse me, it will produce the lower level of output ym, and it will also be cleaner because it's one step ahead in cleanliness. So we can see here that competition, is it clean or dirty ultimately? Does it lead to more or less pollution? There are two opposing effects. One is we call the mass consumption effect, which is represented by this y of delta. As usual, more competition means lower prices. Lower prices means people buy more cars and trucks, etc. And therefore, that increases emission, which is bad for welfare. And then there's the escape competition effect, which is when competition is tougher or expected to be tougher, firm invests more in differentiating themselves by being cleaner. And so there's a reallocation of production. There's a reallocation of production from this sector to this type of sector, which, as we said, produces less and is cleaner. So here's what it looks like. On the horizontal axis, I put competition. On the vertical axis, I put emissions. And then as we go from the top curve to the bottom curve, what am I changing? I'm changing how socially responsible consumers are, i.e., how much they care about, not polluting the planet themselves. And when this effect is weak, we only have this mass consumption effect, and emissions rise with competition. Maybe we can think of, China and India and all these countries that where people now drive cars. As people become more concerned about their footprint, then two things happen. First of all, the curve shifts down, of course, but more interestingly, the profile of the competition's effect changes, it flattens, and then it becomes decreasing. And if we're in this green curve, we can see actually that for almost all the range, emissions decrease with competition because competition is, because consumers care so much about their footprint that firms compete very hard to make cleaner products. Okay, so theoretically, it's ambiguous, but we have these interesting two effects. We don't have data on emissions of each company, etc., so we can't really test it, but it's interesting. In terms of social welfare, it looks a little bit the same. As you increase, I'm not going to show the formulas, but as you increase competition, the standard effect that competition is good is here, namely products become cheaper, people consume more, they're happy to consume more. That's a plus. On the other hand, as competition increases, as we said, the fact that you consume more leads to more pollution, and in the aggregate, that hurts everyone. So the way we formalize welfare is, the utility from consumption, which is increasing as usual in the degree of competition, minus the disutility of aggregate pollution. And aggregate pollution we saw has this hump shape with respect to competition. And so it really depends on the size of psi, namely the size of these externalities. And if we're in the good case, where X decreases with competition, or in the bad case, where X increases with competition. Okay, so now let me turn to the empirical analysis, but I want to ask Anastasia, how much time do I have left?
About 15 minutes, another.
15 minutes? Okay, great, perfect. Okay, so, all right, so we need data. First, innovation data. We turn to the PatStat, the World Patent Statistical Database, which, and we focus on the car sector because obviously, that's a big polluting industry. That's one in which there's a lot of technical change, and that's also one in which they distinguish for us clean and dirty innovations and things we will call gray innovations as well. So in this database for the car industry, and not just cars, but all components, etc., there are two types of patents, two main types of patents we focus on. The ones are called clean. They're anything related to electric, hybrid, and fuel cell technology. Dirty is related to the internal combustion engine. And then there's this in-between classification, which consists of making the internal combustion engine cleaner, consume less, emit less, etc. So that's somewhere in between. And most of our results, we're going to focus on, the ratio or the relative growth rate of clean and dirty, but the results are robust to where you put gray on either side. So what's been happening, with these innovations in the car industry? Here we're putting the share in percent, okay, of clean, gray, and dirty, okay. And of course, there's another category which is called other, which we have, but which is neither, which is kind of neutral in some sense. So if you have, I don't know, better leather for your seats or something like that, that would be something like other. So we can see here that clean has been increasing steadily, and especially from 2005 to 2010 or a little before, and then it's been declining, surprisingly. That dirty here has been increasing as well, but then decreasing. And so it looks like over here, there's been, things have worsened after improving for a while. And then the gray patents have also decreased continuously. And remember, those are the ones that make the internal combustion engine cleaner. Okay, so the news is maybe not as rosy or as green as we thought. Okay. So this is what I mentioned: clean, dirty, gray, and other. This is the picture I showed you before, but bigger. So you can see again the green rising and then falling, the dirty falling and then slightly rising. Okay. Next, we need something about this delta parameter. These how much people care about their environmental footprint, which in the model translates or parameterizes their willingness to pay for to pay extra for a product that is otherwise the same, except it pollutes gamma times less. So for this, we use both the International Social Survey Program and the World Value Survey to have as much data as we want. And the issue is that they don't always use the same question between surveys and even between waves of the same survey. The question for which we have the most observations is this one, which is not exactly ideal for us because our model is not about taxes. It's about, I pay more when I buy my car, but that's the one on which there is the most data. How willing would you be to pay much higher taxes to protect the environment? And then there are two others that we use that are closer to conceptually what's in the model. And we use either just the first one, or we combine them to create an index to cover more countries and periods. How willing would you be to pay much higher prices in order to protect the environment? So that's really what's in the model. How willing would you be to give part of your income? Here it's not saying to whom you're giving it, but you know, it's in the same spirit. These are all willingnesses to pay in one form or another for improving the environment, even though what you contribute, whether it's your taxes or your price or your income donation, these are all negligible. Okay, so people are either willing, very unwilling, etc. And we transform everything into z-scores, and we transform all the variables into z-scores. Okay, so now we have a measure of what we call social values. Here's what they look like for various countries. And it's a little messy here, but by the way, our period over which we'll run these regression is going to be 2008 to 2010, because that's where we have all the types of data we need. But here you see it over a broader period. And surprisingly, until 2010, and this is where the poll in some sense was got it wrong, so to speak, these values were mostly declining. Okay, so people seem to have become less willing to pay in taxes or in prices to protect the environment during this period. There are ups and downs, but the trend is down. Here's another way of looking at it, comparing here 2002, which is the beginning of our sample period, 2012, I think, which is the end. And you can see that for the US, it's go down, for Canada, it's going down, and so on. So this is something that surprised us, and it doesn't seem to be well known. And the question, the reasons are not obvious. Is it environmental fatigue? Does it have to do with the financial crisis? And, when there's a financial crisis and you're losing your home, etc., then the environment, takes a back seat. It would be an interesting study in itself to find out why there was this fall in environmental attitudes. Now, of course, we're in 2020. We don't know. We don't have all the data to run both the patents and the values after that. I suspect that the values have increased back up, whether to their original level, I don't know. But at least we have to hope that they have. And it seems that just from attention that this issue is getting, and from the increased proliferation of green products, fair trade products, etc., one can hope that this has been reversed. But in our sample, it's been a decline, which is going to potentially explain why there has been a stagnation and maybe even a slight decline in the greening of innovation, or really hasn't been as much greening as would otherwise have happened. Okay, so and then I'll mention competition, but for each of these, whether it's values or competition or other country level indicators, how do we transform these variables, which are at the level of a country in a given period or in a given survey wave, into a firm level measure, which we're going to put on the right-hand side of our equation, which has firm level patenting or patenting mix on the left-hand side. Well, we're going to think about the exposure of each firm to social values here across countries. So we're going to compute for each firm a weighted average of the values in all the countries in which it operates by the importance of these countries C for that firm J. Okay, that's what's here. Now, ideally, we would want, for this omega, we would want the share of sales or maybe even the share of profits, but this is not something that's available. What we do have from this database is the share of their patents. Okay, so this is what we use. We use the weights computed using past patenting activity. That is, omega J C is the number of patents filed by firm J in country C before our sample period starts, okay, relative to all of the other countries. We check robustness to alternative weighting definitions, and there's also one econometric specification, which is at the firm cross times country level, which doesn't require any weights. So this, which we do, here I have values, but sorry. Here I have values, but okay, if I replace values by competition, or if I replace values by taxes on oil or oil prices in a given country, I will have for each firm in each period, the initial period and the final period of our sample, their average exposure to different values, different levels of competition, different levels of values times competition, etc. So since I mentioned competition, here's what we use. So we used 3 of them, but in the end, we focus more on the one that's at the firm level, because the main analysis is at the firm level, but also show you some pictures for rougher measures of competition at the country level. So some indicator from the OECD, some openness measure from the World Bank, same thing. We have one of these for each country. And then for each firm, we compute its average exposure to product market regulation or to openness, etc. Alternatively, and this is the main analysis, we go and look at firms, financial and production data, and we estimate an actual markup or inverse market for each firm based on their revenue, their costs, etc., etc. Okay, so this is what we call the learner index. It's a firm level measure of market power or inverse market power. Okay, so let's just look at some graphs. Here is the changes in the environmental value index over the sample period and the relative growth rate of clean versus dirty car innovations. And we see that, it does seem to be upward sloping, in line with the model's prediction or unsurprising predictions that when consumers care more, then firms innovate more in the clean direction. This is the openness measure. It's probably not the best of the competition indicators, but we could draw the graphs with the other ones. You see here that it seems that where there's more competition, and maybe you want to exclude Russia here, there's also more clean innovation. When we use our finer measure of competition, this learner index, this result is going to go away. Competition is going to have pretty much a 0 effect per se. So ultimately, our main specification is to regress the ratio or the relative growth rate of clean to dirty innovations for each firm on its exposure to environmental values across country, its exposure to competition across countries, across its markets, and its exposure to the product of the two, which was the formula from the model, plus we're going to put in, of course, firm effect, fixed effects, period fixed effects, and various controls population, GDP, oil prices, where oil prices includes all taxes, etc. So that's the standard, tool of policy. And that's what we're going to run. Okay, and the model, our simple model predicts that this alpha should be positive, that this beta should be positive, although we already know that that particular result is a feature of some strong assumptions in the model, even in standard models of competition and innovation that have nothing to do with the environment. There are offsetting effects which imply that competition. Philippe Aguillon and co-authors have, a paper where the effect of competition on innovation itself is inverse U-shaped. Here in our model, we are on the good side of that inverse U, but if we step outside our particular model, the beta doesn't have to be positive. On the other hand, there's a strong, robust intuition and a strong, robust result from our model that values and competition should be complements. Okay, so we have in the end 8,000 some firms, okay, of which 2,000 patented in both the initial period and the final period. Here are some statistics on the average number of patents, the average number of clean and dirty patents. We see that overall clean patents grew faster than dirty patents. And we'll be interested in kind of decomposing why that happened and what factors pushed in favor and what factors pushed in the other direction. Okay, so this I showed already. I think I showed this already as well. I'm not sure why it's there as well. Okay, so now we're going to look at these regression results. Okay, so this is our main table, and I hope it's visible to you. So the dependent variable is this, change over time between the initial and the final period in log of 1 plus clean minus log of 1 plus dirty. We can also look separately as the growth rate of clean and the growth rate of dirty. The 1 plus here is for firms that have, zero innovation, or we can look at the change in the clean share over time. Okay, so the main variables of interest are the change in environmental values or in exposure to environmental values of the firm. So this is at the firm level. Okay, so we have 7,000 something observations, and we can see that indeed firms that are exposed to more socially responsible or environmentally responsible values, as stated in the surveys, have clean innovations that grow faster than their dirty innovations. Competition per se, as I said before, that one has very unstable and often not significant effect. The thing that's almost always strongly significant is this interaction between values and competition. That tells us that, so competition may be good or bad for green innovation, but it's better where consumers are more concerned about the environment. It's better or it's less worse. Okay. We can add some control that make certain surely make sense. So here is the fuel price inclusive of taxes, and it's a sanity check also that it increases the relative growth rates or the change in the share of clean relative to dirty innovation. It in particular reduces the growth rate of dirty innovations, but including it doesn't change the main results, namely the significance of values, the insignificance of competition per se, and the significance, except maybe here, and the significance of the interaction. We can also put in this EPS, which is some index of other environmental protection measures, again, at the country level, and we translate it into an exposure measure at the firm level. The effect here is surprisingly not significant or stable, but the important thing is it doesn't change the main results. Okay, we do various other robustness checks, which I won't get into, such as using other weights than the ones we have. The more different and then maybe the more interesting one is to the analysis at the firm times country level. So now an observation is not a firm, but a firm country pair. So, you know, there's many more. There's also a lot more variation to explain. The advantage that this has is that since we're looking at the firm country pair level, we don't have to weight countries to get a firm level exposure measure to anything. So this is kind of free from the somewhat, well, from the assumptions we made about how we compute the weights. And what's interesting is that values become a little less significant, but still positive. Competition remains ambiguous, but values times competition, which again is the key implication of the model, is again strongly significant, even when you control for the fuel price and for environmental policies. And interestingly here, environmental policies do seem to matter. The fuel price always matters. And since this is at the firm country level, this regression, we can put many more controls. We can put, in particular, sector fixed effects and things like that. Okay, so, all right, so it seems that the data seems reasonably in line with the idea that firms respond to consumers' individual social or environmental responsibility concerns, as stated in these surveys, that they respond to it not just because this leads governments to impose, you know, higher fuel prices and taxes, etc., not just because it leads governments to impose higher regulations, etc., but because firms compete harder for these green-minded consumers, and the more competitive our markets, the stronger is this effect. How much time do I have left, Anastasia?
Oh, I think if you could wrap up a little bit so we can have some questions.
So I'll just say that what else we do, but I won't get into it. We do a kind of a, now that we have the estimates of all these effects, we can do some historical counterfactuals. For example, we can say, all right, the actual share change of clean innovations has been 34.6% over this period. What has contributed positively and negatively? And so here we see that the change in values per se has contributed negatively. And that's related to the surprising finding that we had, which is, well, values have declined. So in fact, it has pushed in the wrong direction. On the other hand, where is it? Competition values have declined more in countries with low competition and have increased more in countries with high competition. So this interaction effect helps in the positive direction. And in general, these interactions effect help so that, you know, the decline that is due to declining values, when you look at the composition of where it happened and how it was correlated with competition, that actually is pretty much wiped out. The big impact here is that of the oil price, okay, delta P, that, you know, was in some sense the number one reason why firms became greener in their R&D was because of the rise in tax-inclusive oil prices. So on that list in the survey, you know, that traditional instrument, you know, it is true that you should do all of the above, as shown by this table. The most effective one, when you can do it, is the price, the tax. But to the extent that you're limited along that line, then this interaction of values and competition is important. We also do some perspective exercise that I will skip. So just to wrap up, we find that pro-social concerns push firms to invest in clean innovations. So to some extent, it's not just talk by consumers. And when they answer these surveys, they're actually willing to pay more, or at least it does seem to push firms to invest more in greener automobile products, especially where competition is high. Again, we should remember that innovation is not an objective per se, but behind it is pollution and welfare. And one effect of competition is this mass consumption effect. But where consumers are sufficiently pro-socially concerned, this other effect, which we have demonstrated empirically through this interaction, may offset part of it, or maybe even dominate. So that's another channel, if you want, to the extent that you can that consumers are getting educated or are getting more pro-social, and that this goes along with increased competition. That's another effect that can contribute to making cleaner products and therefore less of an environmental impact. Okay, I'm done. Thank you.
Thank you, Roland, for a very interesting presentation. Before I go to the question, I have one question. I'm assuming your model applies to an industry where firms are producing similar products. So in that particular case, the car industry, where all firms are producing electric or hybrid vehicles, what are the predictions of the model for an industry, the car industry again, that produces traditional cars and environmentally friendly cars, hybrid or electric cars? How does the, maybe I should say differently, what level of environmental preferences would
Okay, so maybe what you mean is that, so here we have these so-called clean technologies, which are mostly electric, hydrogen, etc.
Mm-hmm.
We have these gray that make the, it could be that but we have just one parameter that consumers consumers are just concerned about they don't particularly care if it's electric or if it's a better fuel injection system. They just care that it pollutes less, okay, in the model. They just care about the environmental quality. In practice, it may be that they care more about it being electric, either because it's cool or because they think it's, it's likely to be more environmentally friendly. So is that what you had in mind, where people have?
Exactly.
Yeah. Okay, so we don't have that here. Our consumers are, in some sense, sophisticated in the sense that they care about just the footprint, no matter what form the reduction takes. And then on the patent side, we, in some sense, we go with the classification, which suggests that these are the ones that have the most impact. But our model doesn't have people making a distinction between clean and gray. So that is why when we run our empirical analysis, we do it mostly with clean, dirty, but then we check that it's robust to adding gray or not, because our model cannot accommodate clean and gray. It just lumps these two together in, emissions reducing technologies.
Great, thank you. Gabriela Mundaka has a question that she would like to ask in person. Gabriela, can you unmute yourself?
Yeah.
Okay. Oops. Technological problems.
They're still muted. Oh no,
Yeah, they're still mute.
she's still muted.
Can you hear me now?
Yes,
Yes.
perfect.
Okay, thank you. Yeah, no, I was asking you, how will your result will change? You assume, I have three questions, very short. If you assume instead of a Cournot competition, and that's one question. And the other one is that, do you think there will be some kind of correlation between the fuel prices and the consumer values? Because if the price goes very high or fluctuates, that may change the perception of the consumers with respect to their preference toward environment, right? And the last question
Yes.
is that could you just tell us which is the method of estimation?
Which is the what?
The method of estimation.
Oh, okay. Yeah.
Okay, so that's my question.
All right. So Cournot, we haven't tried, although it might have been among the models we played with earlier on. I think the intuitions are fairly robust. Actually, the first model that we wrote down fully was one in which competition is modeled. So within each sector, actually, products are imperfect substitutes. So there's an elasticity of substitution between, between all within each sector, and the elasticity of substitution parameterizes in the usual way the markup and the degree of competition, and the results were pretty much the same. So at least that other way of modeling competition gives you the same results. Cournot, we didn't look at it, or I don't recall, but I don't see why this intuition that, when you compete harder, you try to get closer to what the consumers really appreciate. And if they appreciate more quality than quantity, then you're going to go more for quality. So I think that would be robust. Your second question was, so let me go to your third question. The estimation is basically, OLS, although we did also some Poisson and things like that, because innovations are discrete, but there's no instruments or kind of anything more sophisticated than that. In the main analysis, if you look at the paper, actually for the degree of competition, there are some concerns that our competition measure could be endogenous. So for that, we have some instrumentation, but not for social values, but for competition, we have some instrumentation. And sorry, I forgot your second question.
Yeah, no, the second was the correlation between.
Oh yes.
So
there is a correlation. Let's see if I can find it. Have it. It's in the paper. No, I don't have it here. So there's probably a correlation, and my guess is that it's positive, and that's really why it's very important to put in these prices in the regression as controls, because if consumers are very concerned about the environment, and the way it manifests itself is that they vote for governments that put in place high taxes on fuel, and you don't have that in the regression, you'll see that you may be attributing the greening of the patent mix to consumers' individual purchasing decisions, as in the model, whereas in reality it comes through they have the government impose higher fuel prices. So it's important to have it in the regression, and indeed these fuel prices have a big effect. That's the biggest effect of them all, but it doesn't make the other ones go away, which means that these attitudes, or which suggests that these attitudes matter more than just by forcing governments to implement high fuel prices and other regulations. They also matter through what happens in the market, the automobile market here, where firms compete.
Okay, thank you.
So one more question from Prasant Gard. Are there ways to measure environmental preferences in real time or with more recent data? Additionally, these are stated preferences. Do you think we could access revealed preferences, perhaps through what people say in public domain?
Okay, that's another good question. So I think if you want, you can have a poll in any given country tomorrow about these things in terms of stated preferences. If you want to have something that covers all the countries or enough countries, like here 80 countries, and you want to have it so that it's comparable, so you can see how it changes over time, I think there are only these big, international surveys, ISS, at least to my knowledge, and world value surveys that are available, and then they are available, because they're big, every 5 years or so. Now, whether Google or someone else can come up with a better, faster measure, I don't know, but that would be interesting. But we are not aware that there is. And in terms of reveal preferences, I guess there are two ways you could do it. You could do it with experiments where you have people actually pay more for cleaner products. Here at the international, at this kind of macro or industry level, I don't know that you can do it directly. We take our findings as, in some sense, revealing that these preferences are not just stated preferences. If they were just, cheap talk, then they would not lead to greener patents, and especially they would not lead to more green patents relative to dirty ones in competitive markets. Okay? If they were cheap talk, just noise, there would be no impact of them. In fact, there is the predicted impact of them, both in level and in interaction with competition. So we take that as, revealing that people do act on these preferences, that consumers do act on these preferences, although it's not, the same as an experiment, but of course it's on a larger scale.
Thank you. So one last question, which I will somehow rephrase, and it is, what can be done so that we can make consumers more environmentally conscious?
I don't really have, there's a whole, I want to say industry, or maybe industry and nonprofit sector that's engaged in that. I think starting with education early on, that's being done in some countries more than in others, and I guess we could imitate the countries that have been more successful in terms of either education or public awareness campaigns. The interesting maybe angle that this gives us is that, okay, so we can do whatever we can with education and awareness, etc. A lot is being done, Greta Thunberg and all that stuff, but it's also important, or the impact is going to be very different depending on something that we can control maybe more easily, which is competition. And so if you're confident that these preferences are going up, or that you are able to make them go up, then you can leverage them and have kind of multiplier effect by at the same time having more stronger competition. On the other hand, if they're going down for some reason, then market competition is actually not going to help you. But I think it's this, this all of the above kind of strategy that was mentioned in the survey. And with, all of the above doesn't mean I don't know anything. We do know from the estimates that, the prices and taxes are the most effective, but we see that they are running into limits, and that these other policies, especially in combination, education and more competitive markets, are effective also to some degree. So that's what I would say.
So I think our webinar is coming to an end. Thank you very much, Roland, for a very interesting presentation.
Thank you.
I would just like to remind our audience that our next webinar is on October 11th. Our speaker is Nick Mueller, and he's going to talk about green interest rates. Thank you very much. Bye-bye.
Thank you. Take care. Bye-bye.